Hey guys, this is the video you guys have been waiting for. I have had a lot of responses for needing help with IPs for my own students and everybody out there in YouTube. So this is going to be a complete video, nice and easy, on IP addressing. I'm going to go over all the different types of IPs, meaning the classes, default mask, ranges, private classes, ranges, mask, okay? And then we're going to get into the assigning of IPs, subnetting. Now I'm going to go over in this video as far as route summarization, and I'm not going to go over VLSM. Those will be two separate actual videos that I'll be doing probably next week or the following week. Alright, so I can upload them. This is going to be at least to get you going with IPs and subnetting. Alright, so we're going to start from the very basics, all the way to subnetting. So take notes. Okay, so first, let's learn the classes, or I'm going to tell you what the classes are. So we have the classes, which A, B, and C are the ones we normally deal with, but I'm going to tell you D and E as well. Okay? Even though A, B, C are the ones you work with. And the ranges. Now, this is the entire range. Okay? This is going to be the ranges from 1 to 126, 128, 128 to 191, 192 to 223, 224, all the way to 239, and 240 to 255. Now, let's put the default mask, which is the CIDR. Okay, CIDR, C-I-D-R, which stands for Classless Interdomain Routing. The CIDR for an A is an 8, the CIDR for a B is a 16, and the CIDR for a C is a 24. Okay, that does not apply to these two down here. The D is for multicasting, and the E is for experimental. What type of experiments? I haven't a clue. All right, every book that I've read, everywhere I've seen, it just says experimental, so don't worry about it because we don't get tested on it. Okay? And we don't even use them. Now, when we talk about the ranges, how we classify, okay? If it's an A, B, or C, it's not, these ranges are in the first octet. And an IP version 4 address has 1, 2, 3, 4 octets, meaning there's 8 bits in each one. 4 is 32-bit address. IP version 4, 32 bits. So when we classify an IP address, we're looking at the first octet. So if you see that there's, let's say, a 111 here, well, that falls in this range, therefore that's a class A. By default, it will have a CIDR 8. So by looking at the first octet is what we know, how we know if it's a class A, B, or C, or D or E, whatever the case may be. Alright? Now, there's some addresses here that I didn't put. What happened to the 0? What happened to the 127? Okay? 0 is reserved. It is the universal gateway. We use it for default routes. Therefore, 0 is not used. And 127, we all know it's a loopback. Now remember, in IP version 4, the entire 127.0.0.0 through 127.255, all that's loopback. Yes, do we ping 127.0.0.1? Yes, that's how we test it. When you go on your test, that's the address that you got to put down. But anything in that range will give you the same thing as the 127.0.0.1. Okay? So now, that's the reason we don't use those two in the range. Okay? Alright, so now you know your classes, A, B, C, D, and E, and their ranges. You just need to memorize them. There's no math involved here. Basically, it's memorization. Another thing, the CIDR, which is the subnet mask, it has nothing to do with the class of address. You can have a class A with a 16 mask. You can have a class A with a 24 mask. That means it's just a class A that has been subnetted. Okay, we'll do subnetting later. So don't let anybody tell you that, oh, if you have something that you classified as an A but has a 24 mask, that means it's a class C. That is incorrect. That is false. All right. So These are your entire ranges. Now I'm not going to focus anymore on the D and E, so I'm going to erase these, okay? And I'm now going to give you the private range. The private range. Which private meaning they are not routable on the internet. They're not routable on the internet. So a class A is from 10.0.0.0 all the way through 10.255.255.255. Now yes, this is a 0. I know my handwriting is something to be deserved. Okay? We classify it. It's an A, right? First octet falls in that range. They decided, powers that be, that the entire 10 is going to be private. So that's the entire range, and the default mask naturally is a CIDR 8. Okay? Now for the B, 172.16.0.0 through 172.31.255.255. Okay, now, careful here. Yes, it's true that a Class B address by default is a CIDR 16. You input anything that starts within the 172 or from the, from the 128 to the 191 inside your properties of your TCP/IP, and you hit tab, yes, it's going to be a 255.255.0.0. But I'm here to tell you now that why did they choose from 16 and 31? The default mask in a private Class B, excuse me for a second, I'm about to sneeze. Ooh, sorry about that. A little dusty. Alright, 16 and 31. What is the default mask there? It's not a CIDR 16, right? It's a CIDR 12. So for a default Class B, the mask is a CIDR 12. Okay, a CIDR 12, and I'll work it out in a little bit after I tell you the Class C address, because you can probably see it a lot easier. And I'll work it out to show you, to prove to you that it is a 12. And a C is from 192.168.0.0 to 192.168.255.255. And here again, we have a little different masks for privates. 16. Because where is that imaginary line? Right here. You see the 192.168 doesn't change. It's the same. The ones that change are the last two octets. Okay? Therefore, the default is a CIDR 16. Do we see this in the properties of the TCP/IP? Of course not. We hit a tab, boom, it gives us 255.255.255.0. Yes. That is the default mask on your test. That's what you answered. But no. How do they come up with all these, the third octet changes? Because here is your line, right? There is the network portion. There is the host portion. That's how come this number can change, right? From 0 all the way up to 255. So once you start doing the subnetting, you'll see it. Now I'm going to show you, now I'm going to erase this. I hope you wrote this down. Again, this is something you must commit to memory. If they ask you a question like this in the CCNA, be happy. You'll pass it 1, 2, 3. Okay? But they're not. If they ask you to classify an IP address, unfortunately they want to get silly about it. They're going to put it in binary and tell you, hey, the following binaries, which class of address are they? Or something to that effect. Alright? But anyway, you need to commit it to memory. And remember, what does it mean to be private? It means that they're not routable on the internet. That's it. Okay? You can't place it on an interface that's facing the backbone, the internet, or nothing like that, because it's not going to work. Alright? That's why we use what? NAT. That's right. Okay. So let's get rid of this. Alright. When we're doing, to answer any question in IP addressing, all you need to know are your bit values. You know your bit values, you're good. You can answer any question. Alright? Now we know our bit values are, let me stand a little bit over here, give myself some room to work. 128, 64, 32, 16, oops, 8, 4, 2, and 1. Ooh, that's a big one. Okay? Every octet has these increments, correct? Because when we look at an IP version 4 address, right, it's broken down into 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now you know space. Let me get on this side. 1, 2, 3, 4, 5, 6, 7, 8. So we got 4 octets. 4 octets, okay? Separated by a decimal. These bit values on top, on top, on top, on top, on top, on top. Because the bottom, we're going to go ahead and count for subnets this way and host the other way. Alright, so it's 128, 64, 32, 16, 8, 4, 2, 1, and so forth. It doesn't change. They're the same in each one. Okay? So, if you are given a mask, which somebody was asking a question about a CIDR 28, right? So let's put CIDR 28 right here. CIDR, C-I-D-R, 28. What does that mean? It means you got 28 bits on. Okay, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, little switch, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And then the rest are off. Okay? So your imaginary line is right here. So this last octet, this 4th octet, okay, is where your focus is at. Everything this way is the network, right? You can't mess with these. These are all on. So this is your network side. So how do you use this up here? Well, this is 1, 2, 4, 8, 16. This bit value here is 16. If you were to add these bit values, 1, 2, 4, and 8, that's 15. This is how your network increments. This is how your network increments. Okay? So, this number is to help you calculate for broadcast. So I'm going to do just a couple so you can see. Alright, let me get another color. Let's do it in green. I'll make it slightly bigger because I know I'm doing it kind of small. Alright, so let's do the first network. I haven't been given a class or anything. I know the X's will represent the octets that are fully on. That won't change. So X, 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 16. Right? That's my first network. I increment by 16, therefore X, 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 32. I keep incrementing by 16, X, 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 48, right? 16 plus 16, 32. 16 plus 32, 48. And it goes so forth and so forth all the way down to the very last subnet. Now, that's your ID, your network ID, your subnet ID, whatever you want to call it. That is what tells you the network that's on the wire. Now the next one you need to find out, let me erase this little line here, is the broadcast address. Okay, how do you get that? There's 2 ways, very simple. 16, right? This 16, not that. 16 plus this 15 is 31. These other 2 addresses, this is your broadcast, and let's put BR. These are the 2 addresses that you cannot assign. And you know very good and well that if you put that one of those addresses with that CIDR 28 and your TCP/IP on a route or whatever the case is, it's going to scream at you. It's not going to let you do it. But on the exam, of course, you're going to put the wrong IP address and you need to figure out why the problem is. So once you got the 2, right, that you cannot put, then what's in between? Well, what's after 16? The number 16? 17. What's before 31? 30. That is your range. This is what you can assign to the computers. Whatever these 3 numbers they gave you, it doesn't matter. This could be 1011. This could be 192.168.100. It does not matter. Okay, what they gave you. This is what you're looking for. The network ID, the broadcast address, and the usable range. Alright, let's go to the next network. 32 plus 15 is what? 47. That is the broadcast address. Okay? So you have from 33 all the way to 46. Alright? Now the last one is 48. 48 plus 15 is 63. What's in between? 49 through 62. That's it. You're done. Network ID, broadcast address, and range. You can do it the way I just told you, right? You get your network increment and you increment down. And then you add your network that you have here to the broadcast calc number. This number, 15 and that. And I'll give you the broadcast so it's easy to know what's in between. Or just increment and then one less, the next network is the broadcast address of the first network. See that? So the broadcast address of 16 is 1 less 32. The broadcast address of 32 is 1 less 48. And if you keep going all the way down, that's the way it works. That's why I tell you, you only need to know the increment. Once they give you the mask, if they give you the mask, boom, where's my increment? Oh, my increment is 16? Okay. 16, 32, 48, 64, 80, 96, 112, 128. And then you just add that 15, or 1 less this network is this broadcast. 1 less this network is this broadcast. Up and down, up and down. Simple. There's no need to waste time. Okay? Now, that's if they give you a mask. That's if they give you a mask. But let's say they don't give you a mask. Okay? Let's say they don't give you a mask. Let me redo this last octave. Well, let me see if I can erase. No. Let me see if I can erase this just like this right here. Let me see. Not that precise here. Maybe let me just erase the whole thing. Let's say they don't give you a subnet mask. They say, well, you got so many hosts. You're required for so many hosts. What mask would you use? Okay. So let's say they give you, I don't know, 100 hosts. You need a subnet mask that would allow you 100 hosts. Okay. I'm going to start from the right to the left. That's how you count for hosts. Right to left, you count for hosts. Right to left, you count for hosts. That's it. So 100 hosts, I'm going to be in the last octave. Hey, Elias, but how do you know that? Because one of the things you need to start getting used to seeing, they're not going to go, if they do, wow, that's pretty nasty. But if they do, you know, they won't do that. They won't do that. As far as hosts are concerned. The first 2 octets, they won't mess with you as far as hosts. Maybe in the last 2 octaves. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, how do I know 100? Well, because I know where 100 falls. It falls over here. How do I know that? 2, 4, 8, 16, 32, 64, 128. That's my imaginary line. But let's keep counting, just so you know. 256. 512, 1024, 2048, 4096, 8192, 16384, 32,768, and 65,536. Did I memorize the hell out of it? Yes, I did. Okay, I did memorize it. I've been teaching it for a long time. These numbers, like, they just pop in my head. But at first I didn't. I had to actually calculate it, okay? I had to add and add and add and add. But finally, yes, I memorized it. So I know when they give me a number of hosts, I know if I'm working on the 4th octave, on the 4th octave or the 3rd octave. I know more or less where I'm going to be. So in this case, they're looking for a subnet mask that's going to allow you to have 100 hosts. So I counted from right to left, starting by 2 and doubling as you go. Now remember, always, 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 always on the whole side, you subtract 2. So here you really have 126. And why do you subtract 2 on the whole side? Because on the whole side, you got to take out what? The network ID and the broadcast address. If you said that, good for you. Alright? But now you know if you did it. You subtract 2 on the whole side. On the network side, for today, they like to play that game. Use the zero network. Don't use the zero network. If you're using the zero network on this side, you do not subtract 2. If you use the zero network, you do not take away 2. If they tell you, don't use the zero network, then take away 2. Alright? And I'll go a little bit about that in a second. Alright? So there's your mask. So there's your line. So what's your mask? Well, you got 8 bits on here. You got 8 bits on here. How many bits you got here? Well, 1, 2, 3, 4, 5, 6, 7, 8. You got another 8 bits there. 8 times 3 is 24. And you got one more bit on there. So your mask is a cider 25. That's it. 25 bits on. Same rocket science, the same physics. Okay? Simple, simple. 2 plus 2 equals 5. I mean 4. Alright? So it's very easy to do. Okay? Again, if they give you the amount of holes, right to left. Once you draw a line, you're good. Let's do another one. Alright? Let's say they're looking for 500, or let's say 300, instead of holes, subnets. 300 subnets. Well, now we have to count from left to right. Now you know, I already told you, the first two are always going to be there. They're not going to, well, that's not true. It all depends on the amount of holes. Okay, 300 subnets with around 100 hosts again. Okay? So, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Those are the two octets that I'm working with. 300 subnets with about 100 hosts. Let's count for subnets this time. They need 300. 2, 4, 8, 16, 32, 64, 128, 256, 512. There's my line. How many hosts? We did this one before. So these are subnets. Now I'm not going to subtract 2 because we'll use a zero network. Now I'll go for host. 2, 4, 8, 16, 32, 64, 128. Okay? So what's my mask? Again, all these are on. Therefore, is a cider 25 again. Okay? It's a matter of just playing with that line. Okay? So now, that mask is what you need for 300 subnets. They'll never give you something that, if they say, let's say I need 300 subnets with 100 hosts, they're not going to make it, or let's say they tell you 300 subnets with 300 hosts. They can't do that. They can't do that. Okay? Because it won't add up. It won't add up. Alright? So, let's do it a little different. So remember, all you really need to know is that and know more or less where to draw your line. Once you draw a line, you can answer any question. Another way that they may come around to you and ask you, they'll give you an actual IP address. Alright, and then they'll say, what is the broadcast address of this IP address? What is the broadcast address of, the network ID, okay, of that particular IP. Alright? So, let me see, let me pick one. I'll pick it on the 4th octave, so it's not that difficult. Let's do, alright, let's do a 192.168.100.97 using a CIDR 27. And they said, what network does that IP fall in? What is the broadcast address that that IP has? And what range? So you need to know the network, the range, and the broadcast address. Okay, again, 27. This is all you need to focus on. 27 bits on. So you have X, that's 24 bits. Why do I put X's? I'm lazy. I don't feel like writing the numbers again. That's not going to change. So 24 bits on. 3 more, right? 25, 26, 27. And then we have 5 off. 1, 2, 3, 4, 5. There's your line. That's it. So you need to find out what this increment is right here so you can increment because your focus is the last octave. So once you find out the increment here, okay, that increment number, you know how to increment by. So what is that increment number? Well, the increment number is 32 because what? 128, 64, and 32. So we increment by 32. If we add these guys together, is 31. And have you noticed, this number here that we used to calculate for broadcast is always one number less than the network increment. I mean, yeah, you can add, you still be the same thing, but it's always one less. Now, I always get people that say, well, I don't do it that way. I do another math. I count with my toes. Listen, I don't care how you do it. Whatever is easiest for you, you go for it. The whole thing is to pass that certification. And because you know when you get out there to the real world, these IT guys, the majority of them don't know how to do this unless they've been working this for a long time. They use calculators, okay? But until you get there, you better know how to do this, okay? And for right now, this has been the easiest method. But anyway, so 32, and you need to get to 97. So let's find out. The first one is 32. I'm not using 0. You know there is network 0. That's what they need. They use the 0 network. Using the very first one and the very last one. Okay? So I'm going to start with the increment 32, 64, 96. Okay? If I increment one more time, that's going to be 128. I'm going to go over 97, so I have to stop there. Let's find out the broadcast. Well, 96 plus 31 is 127. What's in between? 97 and 126. You're done. So that IP address, that 97 IP address, falls in the range of 97 to 126, belongs to the 96 subnet, and has a broadcast address of 127. That's it. Again, the whole trick to this, which is really not a trick, is simply just finding the increment number, and then incrementing to that particular IP without going over. You could have gone over. I could have gone all the way to 128, and instead of adding 96 and 31, I could say 1 less 128 is 127. Well, it depends how you want to do it. But you got to make it quick. Because when you go take that certification, I tell my guys, you got 30 seconds or less, okay, to answer any IP addressing question. Because where you want to focus on is EIGRP, NAT, access list, okay, switch questions, okay, like spanning tree. This is where you need to slow down, all right, and focus on what they're asking you, all right. One of the simulations that they've been giving lately, from what I gather when my students come out of the exam, is a 5-part question on show commands just on the switches. Looking for names and neighbors and all that. Show CDP neighbor, show MAC address table, show interface trunks. These are the things that they ask. These are the simulations where you need to pay attention to. EIGRP, there's an EIGRP thing that they're doing out there now, okay? We're just troubleshooting EIGRP. That is not as difficult. You better know how to configure. Now we're making videos on how to configure all this stuff. You can answer all the questions correct. You mess up, you screw up one configuration, it could be a possibility that you do not pass the CCNA. Alright? I do not believe in paper CCNAs. I do not believe in paper MCSEs. One thing is going to school, memorizing a bunch of stuff, just spitting it out when you get to a test. But once you get out there in the real world, you better know what you're doing. Because if I were to hire you, I wouldn't give you a written test. I'll put you in a room with switches, routers, PCs, and I'll make you do it. If you can't do it, see ya. Okay? So, know this, because this is very simple, IPs. Let's just learn that and get that out of the way. But please, practice your configurations. But again, I'll be making videos for that as well. Alright? So there's another way they can ask you that question. Alright? Alright. And you can see, again, it's just finding the increment. And let me show you earlier when I said that the class, private class B, is a private class B does have a CIDR 12. Okay? Watch this. A CIDR 12. Okay? That means 8 bits are on. 1, 2, 3, 4. 1, 2, 3, 4. That's 8. Now I'm not going to put the rest of them. We know they're all zeros. Let me get it. These are all zeros, okay? And these are all zeros. You know, you got A00 and A00. I'll run out of space. But your focus is the second octet. That's the CIDR 12. Your bit values, 1, 2, 4, 8, 16. This increments by 16. Alright? You add this together, that gives you 15. Now you know 1 less 16, right? If you add all the 8 bits here, it's 255. If you add all the 8 bits here, that's 255. So let's take a look at that private class B, right? Let me get rid of this line real quick. You have 172, first octet, 16, 0, 0, right? Off, off. Now what's the broadcast? Well, second octet. Second octet. I need my 15. 15 plus 16 is what? 31. Third octet. Third octet. 0 plus 255? 255. Fourth octet. Fourth octet. 0 plus 255? 255. Is that not the private range for a class B? I think so. That's why that the CIDR 12, you can go using a private class B address all the way up to there. So if you were to count the hosts, which I'm not, because this goes beyond 65,535, you keep doubling as you go. A couple 100,000 IP addresses, okay, for the private use of a class B. A couple 100,000. You do the math, just keep doubling as you go, okay? But to prove to you, and now this time, look, this is subnetted. But what changed from the last one that I was doing? Because the last one, I was just focused on the last octet. I simply took that same concept and brought it over to the second octet. I drew my line, I found my increment, which I'm incrementing in the second octet, okay? Started with that, 16, 0, 0, off, off. And then the numbers on the second octet to broadcast, all right, my broadcast calc numbers, that's it. So I add the appropriate broadcast calc number to the appropriate octet. He's in the second octet, I add it to the second octet. Is in the third octet, I add it to the third octet, and so forth. Fourth octet, fourth octet. That's all there's to this. That is all there is to this. It doesn't matter in which octet the line is. You need to find this magical little line, and you're going to answer every question you can possibly think of on IP addressing. All right, I'm going to do one more. I'm going to do one more. All right. Let me see. Let's do a mask. A mask that they normally like to use. Okay. Let's do a mask differently. Let's do a 255.254.0. Let's answer every possible question that we can. Let's put how many networks it has. Let's put how many hosts it has. Okay? Let's find out the networks. Let's find out the broadcasts. Let's find out the ranges just by this mask. First two octets are on. X, X. Can't do nothing with it. Our focus is this third octet. 254, how many bits are on? 7. 1, 2, 3, 4, 5, 6, 7. And then you got the 8. And then of course you already know all that is zeros. That way. Our imaginary line, right there. Right there. Bit value of 1, bit value of 2. Alright? We add this all together, that's 255. We don't have nothing to add it, so it's 1 right there. So, how many subnets do we have? 2, 4, 8, 16, 32, 64, 128. We'll use the zero network, so we will not subtract 2 here. So we have 128 subnets. How many hosts do we have? Starting counting from this way, the bit value here, the last bit value on the fourth octet, it will be 256. And then we have 512. But we have to subtract on the host side 2. So that's 510. So we have 128 subnets with 510 hosts on each subnet. So we got that out of the way. Alright, so what's the first network? We're using the zero network, right? So X, X, 0, 0. So what is the broadcast address of this 0.0 network? Well, 1, which is in the third octet, plus this third octet. That's X, X, 1, fourth octet up here, right? 255. What's in between? 0.1 through 1.254. Now guys and gals, my students also have issues with this. They like to say 0.254 or they get confused. Think of this as your car, the odometer. If you roll back the miles, this has to go all the way back down to 0, right, before this can become 0 again. Okay? So when you say what's before this, is 1 less this guy. Alright? Until it rolls down, rolls down, rolls down, then you know, this will start turning to 254 really. Okay? So remember that. Remember that. Alright, so what's the next network? Well, we increment by 2 on the 3rd octet. 2 dot, what's off? The 4th octet, 0. And if you look here, maximum, right? Maximum value of this octet. Flips this guy over to 2, resets itself back to 0. Just like a car. You drive 0, 0, 0, 9. Once you drive 1 more mile, you got 0, 0, 1, 0. Just like a car, an odometer in a car. So again, now what is the broadcast for this one? Well, 2, 3rd octet, plus the broadcast calc number on the 3rd octet is 3. 0 plus 255, 255. Okay? Now you got, what's in between? What's after 2.0? Or think of 20 miles. 2.1. What's before 3.254? Or 3,255, 3.255. 3.254. Okay? So now we know how many subnets, how many hosts, what networks, IDs, right? We can keep going all the way down 128 times, but I'm not. Okay? And following the same concept. Following the same concept. Okay? I hope this clarified a little bit. Okay? As far as this is subnetting. The rest of it is just classifying an IP address. Default mask. What's a private IP address? They're going to ask you things like, which are valid hosts? So, what is it you do? Take a look at that mask. And then based on that mask, increment down. If it falls here, that's a network ID. If it falls here, that's a broadcast, not a valid host. If it falls in the middle, that's your usable range. Those are valid host addresses. The subnet mask, the CIDR notation, that is the key to answering all these questions. Before I let you go, I'm going to show you the CIDR notation again. People are wondering how I came about that. All right, how do I get that? It's a bit to decimal table. Okay? One bit equals 128. 2 bits equals 192. 3 bits equals 224. 4 bits equals 240. 5 bits equals 248. 6 bits equal 252. 7 bits equal 254. And 8 bits 255. What does that mean? 1, 2, 3, 4, 5, 6, 7, 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. That's what that means. Consecutive bits. That's why when somebody gives me a mask, I'm like, oh, 21 bits. That means 8 and 8 is 16. The first 2 octets are on. I have 5 more bits. 5 more bits is a 248. I already know where to draw a line. Once I draw a line, 1, 2, 4, 8. I know my increment. Boom. Just like that. So this little table is very handy because, again, the key to answering all your questions is the subnet mask. So I'm going to do 4 examples of masks. Okay? I'm going to do it here on the right, on the left side of the board. I'll do it in blue. Alright, let's say they give you the normal one that they like to give, CIDR 28. So you have 4, right? 1, 2, 3, 4 octets. 28 bits are on. 8, 8, and 8. That's 24. How many more bits you need for 28? 4. 8, 8, 24 plus 4, that equals 28 bits. Okay, 8 bits is what? 255. 255. 255. And 4 bits is 240. Let's do a CIDR, and watch this, a CIDR 20. Right? 1, 2, 3, 4. 8 and 8, 16. Plus 4, that's 20. Nothing else. So 255, 255, 240, 0. Look at that. And then a cider 12, which we did earlier. 8, oh, I'm sorry. There's 4 octets here, right? 8, oh, on the bottom, guys. 8 plus 4, that's 12. 0, 0. So 255, 4 bits on is 240. And I can't, oh, you couldn't tell that 240 from anything. 240, 0, 0. All these have a 240 mass, and guess what? They all increment by 16. Just on different octets. The subnet mask is going to let you know what octet you're going to focus on. Okay? But this is all you need to know. And know your bit values. Because once you draw the line, what you're looking for is, oh, what's the bit value here? Well, the bit value here is 32. So my network increments by 32. 32, 64, 96, 128, 160, 192, 224. Boom, that's my last network. Okay? That's what you need to know, and that's how quickly you need to do it. Alright? But I hope you wrote this down. I tell everybody to do it, and they never want to do it. You know this table. You know the bit values. You can answer any question. Alright? I will be having a webcast come March 10th, okay, 1 p.m., U.S. Eastern Time, okay? It's going to be on IP addressing, subnetting, route summarization, VLSM, once again, hexadecimal. If you guys are interested, you can email me at info@thenetworkingdoctors.com or thenetworkingdoctors@gmail.com, okay? Go to the channel. I'll put maybe I don't know, 30-second video letting you know about the webcast, if it's going to happen or not. I need to know at least by February 24th if you guys are really interested in it. If I have enough people that are interested in it, we'll go ahead and I'll do it. And it's free. You don't have to pay anything. All right? It's free and no materials needed. If you need anything, I'll email it to you, or I'll probably have, I don't know, like, what do you call that thing? I forgot, Dropbox or something like that. I'll put something up there. You guys can download it for notes, step-by-step configurations, all that. Okay? So you guys can download it so you can have it if you need any materials. But remember, it's going to be March 10th at 1 p.m. U.S. Eastern Time. Okay? And it's free. It's free. It's no charge. All right? To help you guys out. Website, sorry, I'm still working on it. I want to make sure that I get stuff up there right. And I will be doing videos like this, categorized. Alright, so this was on IP addressing, basic IP addressing subnetting. The next one will be on VLSM. The next one will be on route summarization, so I can separate them all. And then we'll get into the different routing protocols. Unfortunately, I don't know how mundane the next category will be, but I need to talk to you about OSI, TCP/IP, all that stuff. You need to know that. It will really be nasty if you get questions wrong on the OSI model and then you fail the test. No. Okay, so we don't want that. But anyway, I hope this helped. If it didn't, keep the feedback. I like it. Good, bad, whatever the case may be. Just keep the feedback coming, and that's it. That's it. So keep in touch, and you'll be seeing a lot more videos.